Hello TechStars and welcome. The following are a set of designs in the form of an actual demo. I don't actually have a product, so I'll just be sharing with you the designs from 2021 when there was an engineer on the team. In 2021, we did sprints from pretty much January going into September when Roos had left the startup or the project. And so I just made the space available for him to innovate and be creative while providing the strategic direction of what needs to happen and setting that and doing the training and the mentoring with regards to how the day and the week and the month should be structured. So we first started learning about rockets. So we found some courses on the web, downloaded the software, got the simulations going, and after a couple of weeks, maybe a month and a half, 2 months, we had the rocket go up 2,700 meters in the simulation, and that gave us the confidence to move on to other things because we didn't want to be in the rocketry business. It's already saturated. It was already saturated in the 2021 kind of environment, and it's more competitive now. So we started focusing on tinier, kind of smaller innovations that, how to get more fuel into the fuselage. Just kind of working on that, just kind of increments to how does a robotic arm work, because we wanted to make it work to then put it on our rail system, which we imagined would be the connector between the two different nodes of our factories, because we want to make factories in space. Because what we want to solve is manufacturing and abundance of food, so that we can solve food, we can solve housing, we can solve manufacturing without wrecking the planet or making pollution in in outer space or anywhere. So just kind of taking baby steps to work towards the vision, one step at a time. So we started working on the kind of simpler designs for the AMU, which is the autonomous manufacturing unit. I'm going to talk about the next slide, to some of the other inventions like a greenhouse in orbit, because we wanted the factory to make this thing so we could have abundance of food. The autonomous manufacturing unit, or AMU, now this invention is designed to make a copy of itself. It's all hypothetical. In addition to that, it can reorganize itself internal to its structure, so that instead of making panels that can be reassembled or making copies of itself, it can make an invention of our choosing, which would be, one of the examples would be the greenhouse in orbit or on surface that I just shared in the previous slide. I'll share a little bit more about that in the next slide, by the way. But the concept is that the material would be provided by a transporter into one of the units for the main unit for the AMU, where it's going to be processed, it's going to be melted, whatever needs to happen happens in this facility, is then going to be cleansed and packaged so that it can be stored in the other unit. And so these robotic structures, whether it's a Canadarm or Git AI, which is a Japanese-American collaboration, or something else, I don't really have an agreement with anyone right now. This was the concept, that you have a robotic facility moving materials, and then you have an autonomous structure inside of the buildings itself for making what you want to make, and then storing what you want to store. So then come the time, the transporter can then transport the material where it needs to happen, where autonomous robots again would assemble the constructs, or semi-autonomous or remotely operated machinery at that. That's the concept in a nutshell. Primarily, the three parts of the AMU would run on solar power, but if that wasn't sufficient for some reason, there would be some auxiliary power. The backup power for the transporter alone, because we didn't intend to run the main units on hydrolocks, but there would be fuel depot in case the transporter needs to recharge for whatever reason. but this may be optional. So the intended purpose again of the AMU is to solve manufacturing, move manufacturing away from Earth, particularly heavy manufacturing. All the heavy polluting industries can safely in the future, as is hypothesized, move to an AMU facility, whether an AMU facility is in the shape that you see, or if it's a kind of Walter B. Myers kind of design of a hollowed out asteroid, and you got manufacturing happening in there, or something like a synthetic satellite, not in the sense that we have today, but something a little larger that is very closed looped, and it doesn't leak, and there's no toxic stuff coming out of it. So we could, in theory, have an AMU be the precursor of moving manufacturing away from Earth. Ideally, I'd like it to be in a very closed environment, whether it's in orbit or on the surface. But in addition to solving manufacturing, AMU, conceptually speaking, would have the capacity to solve food security also, and I'll talk about that in a moment, as well as turn the present day reality whereby we have a scarcity of organs on our planet. It's actually like pretty bad situation, has been a pretty bad situation with regards to the shortage of organs. Well, we could turn all of these problems into opportunities with a simple design like an AMU. On the topic of food security, the AMUs again could be reorganized to make panels, which could be basically combined together to make a structure whereby you could have vegetables and greens to begin with, grown in a greenhouse, whether it happens to be in orbit or on a surface, maybe the Martian surface in the future, Earth's moon, maybe an O'Neill cylinder. This is a very simple, the work that you see overall is about 776 to 800 hours between January to September of 2021. And this probably took us a week and a half, 2 weeks to go from like back of the envelope designs to something like we basically did a lot of sprints. But you get to product refinement by continuing to talk to customers and then going back to the drawing board to solve the problem the customers have. This is based on a finite amount hours of work. So similar concept for this design. Also, you've got a rail structure, but as opposed to moving a lot of material, so to speak, it's this design is focused on the planting, the tending, the caretaking, the hygiene aspect, and the control, because you don't want stuff like mold and what have you to break into a closed loop facility like this. So that is what the ARM is designed to do. Obviously, there's going to be other technologies here with the rise of computer vision, machine learning in general. You can indeed have an autonomous facility here on Earth, or in a non-terrestrial sense, whereby you can then take the steps towards solving food security. I have to highlight that the panel you see at the bottom with the circular two designs in it, like looks like buttons. These are actually designs from the patents in the public domain for planetary resources, and I have to highlight that because we borrowed from their designs. Otherwise, the designs are ours. They're simple designs. So, like I said, these designs can be implemented here on Earth under the surface, provided there's a cleaner source of power powering these facilities, and they're you're going to have controls, obviously, if they're on Earth, like security controls, and like if you're going to be sending human observers for monitoring these facilities, then all those technologies would have to be developed, because you don't want the robot arms to do anything really, while there's some kind of being around, or some kind of creature, like a pet or maybe even an insect. So yeah, this is the concept of the greenhouse in orbit. Sorry, I took a little longer, but just to recap, the AMUs will make a copy of itself or another invention like a autonomous greenhouse. And yeah, that's it. Thank you very much. Be happy to take any questions. Thank you.